Okay guys, so this second video is a video now on solving linear equations. And the reason we talked about building first was that to solve it, you've got to know how it was made, and then you can build it. So we're just going to have some general rules. The most important thing when solving linear equations is to remember. You've got an equation. You've got something equal to something else. So it's like you've got a balance. You've got scales and they're balanced. If you do something to this side of the equation, so say I add in an extra ball, and I don't do it to this side of the equation, my thing is going to look like this now. And there's no longer going to be equality between this side and that side, alright? So when you're solving equations, the most important rule that you need to know is that always, never, without fail, what you do to one side, you must do to the other. I apologise for my messy handwriting. Okay? So what you do to one side of the equation, you have to do to the other side of the equation. Then the second thing you've got to remember is just a set of rules. So I'm just going to, even though I called that one, I'm just going to write these rules out that you can always check. When you're solving equations, the first thing you do is one, you expand brackets. If you're not sure what I'm talking about at the moment, don't worry. Just write these rules down in your glossary and then we're going to go through some examples. So the first thing you do is you expand brackets. Then you collect like terms. Again, I'll explain that. And thirdly, write out your building steps and solving steps. And then solve. And then solve. So just copy that into your glossary and then we're going to go through an example. You would have had to pause the video to do that. Alright, now we're going to go through an example. It doesn't like getting rid of all my dots, that's okay. So, let's do an example. We had 2n plus 3 equaled something before, so let's go do that one. 2n plus 3 equals 4. First thing we have to do, if you look at your rules, is 1, expand brackets. I'm just going to go EB, expand brackets. Now there aren't any brackets, so you're sorted. Second thing you have to do is collect like terms. All that means is make sure that every little term or thing added together that has the same variable, which is the same letter, is together. So make sure there's only one term, one thing added that has 2n in it, or 2b in it, or 3n in it, or 4b. So you wouldn't ever want to have 2n plus 3 equals 4 plus 4n and try and solve that. Before you do that, you have to get this one and that one together. Alright? So if we go back to our example, right here, 2n plus 3, well there's no other n's around the place, so we have collected like terms, so we're good. Now, our building steps and solving steps. Well, building steps, remember, I'm just going to write this as a table. You might want to write it as something else. Building steps, solving steps. Building steps is, if we started with n and we got to 2n plus 3, how did we get there? Now, if you look back at your rules, you do brackets first. Well, there's no brackets, so we're good. Then you do treat a fraction sign as a bracket sign, no fraction sign. Alright, and then you do multiplication and division before addition and subtraction. So 2n times 3, if you've ever got a number next to a letter, that's really 2 times n plus 3. So what we've done is we've multiplied, we started at n, we've multiplied it by 2, we've got 2n, and then we've added 3 to that. So our building steps are multiply by 2 and add 3. That's how we work out our building steps. And then we want to go solving steps. Solving steps are just the opposite of your building steps. Alright? So solving steps, you start with your bottom building step and you do the opposite of plus 3 first. So the opposite of plus 3, of course, is take 3, because the opposite of addition is subtraction, the opposite of multiplication is division. So we do take 3 first, and then we do the opposite of our top thing, which is multiply by 2. The opposite of that is divide by 2. Alright, so I go 2n plus 3 equals 4. First thing I'm going to do, according to this table, is I'm going to take 3. I'm going to take 3 from this side of the equation. Now remember, golden rule, I have to take 3 from both sides of the equation. So I get left with 2n plus 3, take 3, equals 4, take 3. Now of course we've got plus 3 and we've got take 3, so that becomes 2n equals 4, take 3, which is 1. 2n equals 1. Then we're going to divide by 2. Now a fraction sign is actually the same as a division sign. Alright? So if I put a fraction sign, that's actually saying I'm dividing. So I'm going to go 2n divided by 2 equals 1 divided by 2, because I have to do the same thing to both sides. You can leave 1 divided by 2 exactly how it is. But on this side, we've got 2n divided by 2. We can cancel the 2n and 2. So we get left with n equals 1 over 2. Let's do another example like that. You might want to copy that one into your book. So these are examples for question 1 and for question 5. If you're thinking, oh, I know how to do all this, that's okay. Skip on a bit. You might even want to skip to the next video. So we're going to do another example. 6a over 2 take 3 equals 5. Now, don't be scared by this fraction. Remember, that's a division sign. Right. First thing we're going to do is we expand brackets. Do we have brackets? No. We've got a division sign here, but we can't expand anything. We can't do anything there. So expanding brackets would be if you had something like 2 outside of 3 plus 4. Alright? That's when you expand brackets. We don't have that, so we don't have to worry about it. The second thing is we have to collect like terms. Well, again, all the a's are together over here. Alright? 6a over 2, got all the a's together. We don't have to worry about those a's. Can we do our building steps and our solving steps again? So we started with a. What's the first thing we do to a? Well, remember, multiplication and division comes before addition and subtraction. So the first thing we actually did to a was we multiplied it by 6. Alright, because we've got 6a and we've got 6a. It's the same as a times 6. Doesn't matter which order you do it in. Then we divided it by 2 because we divide all of 6a by 2. So then we divided by 2. And then we took away 3. So my steps are divide by 2, which is 6 over 2, and then take 3. So we get 6 over 2 take 3. So take 3. Now my solving steps, remember they're going to be starting from the bottom one and going up. So the opposite of plus 3, take 3 is plus 3. The opposite of divide by 2 is multiply by 2. And the opposite of times 6 is divide by 6. So that's the order I'm going to do it in. Okay. So here we go. So first thing, I'm going to add 3 to both sides. So I get 6a over 2, take 3, add 3 equals 5 plus 3. Remember, what I do to one side, I have to do to the other. 6a over 2, take 3 plus 3. Well, of course, they cancel out. So you get equals to 5 plus 3, which equals, let's get my right colour, equals 8. Second thing I'm going to do is multiply by 2. According to my list of solving steps, 6a over 2 times 2 over 1 equals 8 times 2. Alright. Now 2 over 1 is the same as 2. Multiplying fractions I can cancel diagonally. You said it. Alright. So I get 6a then equals 16. Okay? And then my final step is that I'm going to divide by 6. Alright? So if I divide by 6, that is actually the same as putting it on a fraction. Fraction's just division. So I can divide both sides by 6. I cancel that one and cancel that one. I get a equals 16 over 6. And if you put that in your calculator, you'll get something like 2.6667. Alright? So that's another couple of examples on solving the equations. I hope that helps you do question 5 and question 1 of question 1 and question 5 of your learning intentions. Have a go, guys, and copy those examples into your glossaries.